Welcome to another episode of Biological Chronicles Live. Today, we will be discussing the riveting subject of different types of pollution and the effect on their environment. On my right, we have Dr. Benjamin F. Greenbaum, a certified water expert who drinks more than 8 glasses of water a day. And on my left, we have Dr. Jenna Carter, a certified air breather. Thank you both for being here. Let's begin with Mr. Greenbaum. Can you tell us more about water pollution?
Of course, I would love to. Water pollution is anything that decreases the quality of a water body. Let me show you how. There are 3 different types of water pollution: point, non-point, and groundwater. Point pollution is any pollution resulting from a single specific point. For example, a single pipe from a factory. Non-point pollution results from the diffusion of multiple sources of contamination. Finally, groundwater pollution is when pollutants, usually fertilizers and pesticides, are able to make their way underground into the waterbed. The major result of these pollutants is an increase in wastewater, which needs to be broken down. This waste is generally broken down in the water by bacteria. This bacteria requires oxygen, therefore we can measure how polluted water is by the amount of oxygen required by the bacteria. This is known as the biochemical oxygen demand, or BOD.
I see. And what effects can water pollution have on this environment?
Water pollution can have many serious negative effects on the environment. When bacteria uses up oxygen to break down waste, biological dead zones can be created. These dead zones are hypoxic environments, meaning areas that are deprived of the necessary oxygen levels to maintain life. One of the largest dead zones on the planet is the Baltic Sea, with a surface area greater than 60,000 square kilometers. Another cause of dead zones is eutrophication. Eutrophication is the dense growth of algae on the water's surface caused by an excess of nutrients polluting the water. This results in the death of plants beneath the water surface as they aren't able to receive the sunlight necessary to perform photosynthesis. Another negative effect of water pollution is biomagnification, also known as bioaccumulation. To understand this process, a basic understanding of the food chain is needed. Do you know what that is?
I know what that is. A food chain is a linear network that represents the different trophic levels that energy passes through. This energy passes through different organisms, beginning at the primary producers and ending at the apex predator species.
Precisely. When toxic pollutants enter water bodies, they can become incorporated into the diet of certain aquatic organisms such as zooplankton. The plankton are then consumed by fish, which are consumed by larger fish, which are in turn consumed by other predators. The concentration of toxic substances in the water increase through each trophic level. The apex predator species can eventually have dangerous levels of bioaccumulation in their tissues and organs. This negatively affects the quality of life in our local ecosystems.
Wow, that's crazy. Whoever knew water pollution could have so many negative effects on the environment? Ms. Carter, can you talk to us about air pollution?
I'd love to. Whew. Air pollution is a total killer, my friends. In fact, it is known that over 4 million people die each year from the condition of the air present in our atmosphere due to its linkage with numerous diseases such as asthma or lung problems. Now, these numbers might not mean much to you until you understand what exactly air pollution is. Air pollution is basically a mix of particles and gases in the atmosphere that can reach dangerous concentrations both outside and indoors. Do you have any guesses about what some of the main causes could be?
Fossil fuels?
Yes. Resources such as petroleum and coal are 2 of the largest contributors to air pollution by way of fossil fuel emissions. Hydrocarbons, fuel, oil, and natural gases are all types of fossil fuels, and they're formed by the remains of dead plants and animals. These products are burned in large factories in order to create fuel to power parts of your everyday life, from the cars you drive to the electricity in your house and even the heating system that keeps you warm in the winter.
Wow, I had no idea me driving to work every day hurt the environment so much. But how exactly does the air get so bad just from burning some coal?
These fossil fuels, while a large part, are not the only causes of air pollution. Other causes can range from agricultural activity to use of harmful aerosols and even methane gas from cows.
Wow, that's crazy. And how does all this air pollution affect the environment?
Besides the aforementioned damage that this pollution does to human bodies, One of the most catastrophic results of air pollution is the damage to the stratospheric ozone and the creation of a hole in the ozone layer, which is more of an impoverishment than a hole. The main offenders in the formation of this ozone depletion are chlorofluorocarbons, or CFCs, which include elements such as chlorine, carbon, and fluorine.
How do these CFCs cause a hole in the ozone layer?
These CFC compounds are created from the use of everyday products such as aerosols, like the hairspray you use to keep your hair in place, and refrigerants, the gases that keep the food in your refrigerator cold, and even halon, a cooling system set in part for use by airplanes and firefighters. When these dangerous compounds reach the stratosphere by way of currents, the carbon bonds are broken by the intense UV radiation, which allows for the escape of free-floating chlorine atoms. These chlorine atoms are then the cause of the depletion as they evoke a reaction of ozone molecules which perish, decreasing the amount of protection against the UV rays.
So, why are UV rays so dangerous, and how do they get in?
Well, in its rightful shape, the ozone normally protects against UV radiation at certain wavelengths. For instance, the ozone layer is able to easily protect against UVC radiation, which occurs from 100 to almost 300 nanometers of wavelength. In addition, the ozone layer can protect against some amount of UVB radiation with the wavelengths of 290 to 320 nanometers. Some of this UVB radiation is still able to get through, especially in the depleted zone. The last type of radiation, UVA, is not protected against by the ozone layer, which is dangerous as the UVA and the UVB radiations are the types most likely to inflict harmful conditions on humans, including cancer, cataract damage, and also weakening of the immune system.
Wow, I've learned so much today about how terribly we treat our environment. I think this is less of a lesson and more of a wake-up call for society to put in some effort and save the lives of the future generations of the world. Thank you all for watching today's episode of Biological Chronicles Live, and we hope to see you out there making a change in the world.
Woo. Woo. We're done.
Radiation at certain
You
wavelengths.
got it? Gosh, okay, sorry. Get out. Okay, good enough.
Precisely. I'll finish the spin over there.
That's the idea. Okay.
You gotta have it.
All right.
Gotta have those-
I don't. When you're. All right.